Hello everyone, very good morning. Today we are going to start a new topic, that is moment of inertia, and this is totally related to center of gravity. What it means, what is inertia, and what is moment of inertia, that we have to understand, and what is the role of centroid and center of gravity in this moment of inertia that we are going to discuss. So, moment of inertia, that is called I. Moment of inertia means it is considered a lamina of area that shown in figure, this one. Let the lamina is split up to the inclined number of infinite, means number of small elements of the area as a dA, like this. This is our area and this is our small part. Number of this small part of this area are there. X1, X2, X3 are distance of small element from y-axis and y1, y2, y3 from here, vertical distance from x-axis. So Ixx is equal to dA y1 square plus dA y2 square plus dA y3 square. So that's Ixx is equal to area into y square. Same way, Iyy is equal to area into x square. Means, what is the moment of inertia? From these two we can say that second moment of area is called moment of inertia. Means, inertia is equal to area into distance of that element from the axis, and moment of that inertia means second moment of area is called moment of inertia. Here we have a two axis of particular element, that is x-x axis and y-y axis. So moment of inertia is always calculated from that two major axis, Ixx and Iyy, and the unit of that moment of inertia, that is mm raised to 4 or else centimeter raised to 4 or else meter raised to 4, because the equation of I is equal to area into x square. That means area, unit of that area is equal to mm square, and the square of this distance is again mm square, means it is mm raised to 4. Clear? So this is our one of the element, and if it is rolled towards the downward, then it is totally stabilized by moment of inertia. Now, radius of gyration. Radius of gyration means a number of small elements are arranged in a manner that the distances are equal. Let's just explain. This is our area and this is our small elements of that particular area, and the distance r1, r2, r3 are the distance of that particular area. So from here IAB is equal to dA into r1 square, dA into r2 square and dA into r3 square. Now IAB is equal to sum of integration dA into r square. Now the moment of inertia of the lamina about AB axis, IAB is equal to dA into K square plus dA into Q square plus dA into Q square, means IAB is equal to IA into K square, means we are just considering that all the small elements are in a same distance, that is called radius of gyration. Let's just explain. The distance from the given axis at which if all the small elements of the given lamina are placed, the moment of inertia about that axis, given axis, does not change. That distance is called radius of gyration. So, I is equal to A into K square, means K is equal to under root of I upon A. This is the equation of radius of gyration. And why we are finding out this radius of gyration? Because whenever we are going to design our any element like beam or column, at that time this radius of gyration having put that maximum importance in that design. Now section modulus. Z is equal to I upon Y, means Zxx is equal to Ixx upon d by 2 and Zyy is equal to I by y upon b by 2, means y is equal to distance, perpendicular distance of that axis. Now this is the different cases of section modulus. Now moment of inertia, some standard section Ixx is equal to bd cube by 12 and Iy is equal to db cube by 12. These are the equations of Ixx for a particular regular shapes. Suppose for this rectangle Ixx is equal to bd cube by 12. This is the derived equation and that we have to remember always. Iyy is equal to d into b cube, means db cube by 12. Again we have to memorize that equation. Now Izz is equal to Ixx upon y and Iyy is equal to Zyy is equal to Iyy upon x. Now we can calculate these equations. Clear? So these are the number of equations that we have to memorize all the time. Semicircular section, quarter circle, these are the equations that we have to always memorize that equations. Suppose this is our half circle and Ixx for this half circle is equal to 0.11 r raised to 4 and Iyy is equal to pi by 128 d raised to 4. For the quarter circle, Ixx and Iyy is equal to 0.055 r raised to 4 and from base it is pi by 16 r raised to 4. So these are the equations that we have to memorize. Now the most important table given over here and that we have to always keep in mind. Without this moment of inertia of regular shapes, we can't calculate the whole body moment of inertia. So what is there? This is our rectangle section. Area of this rectangle section is B and D. Moment of inertia, that is Ixx is equal to bd cube by 12 and Iyy is equal to db cube by 12. Same way radius of gyration under root of I upon A and section modulus Z under root of I upon Y, that we can calculate, but we have to memorize this thing always. Suppose this is square, so Ixx is equal to b raised to 4 by 12 and here again b raised to 4 by 12. Hollow rectangular section, so Ixx is equal to bd cube by 12 minus small bd cube by 12. Iyy is equal to db cube by 12 minus small db cube by 12. That we have to memorize. Again, the most important circular section. Ixx is equal to pi by 64 d raised to 4, and Iyy is equal to again pi by 64 d raised to 4. Hollow circular section. So Ixx is equal to pi by 64 d raised to 4 minus pi by 464 d raised to 4. Both the axes, the same equations are there. Now the most important right angle triangle. Ixx is equal to bh cube by 36. Iyy is equal to hb cube by 36, and at the base bh cube by 12 and hb cube by 12. That we have to remember. Now, equilateral triangle. Ixx is equal to bh cube by 36. Iyy is equal to hb cube by 48, and I base is equal to bh cube by 12. Now, the equations for this I section and channel section that we have to calculate. So, no need to memorize this equation. Now, the parallel axis theorem. This is the most important thing, and this equation is always we are going to use for our each and every example. So, you have to remember this parallel axis theorem. What it called? If Ig is the moment of inertia of plane area about the axis passing through the center of gravity, then the moment of inertia about axis AB parallel to first axis and the distance from the center of gravity is given by IAB is equal to Ig plus AH square. Just we refer that table. We have moment of inertia Ixx and Iyy for the some regular shapes, and that Ixx and Iyy both the axes are passing through the CG of that section. So, Ig is equal to Ixx and Iyy of that particular section. But whenever we have to finding out or else we want to find out moment of inertia of some other another axis which is parallel to Ig, then the AB is equal to Ig plus area into distance square. So, area into h square. Now, here we have the proof of that particular case. This is our small element having some area. This is our strip. So, consider a small element strip of area dA. This is the small strip of that small area. Y is equal to distance of strip from CG. From this is our main CG, means it is Ig, and from here it is Y. Y is equal to distance of strip from CG of that section. The moment of inertia of strip about the CG of the section, that is I is equal to dA into Y square. Now, moment of inertia of the whole Ig is equal to sum of the dA into Y square. Now, moment of inertia whole section about AB axis, then sigma dA into, so whole area is there, h plus y square. Now, solution of this, so sigma h square dA plus 2 sigma h y dA plus sigma y square into dA. Now, a into h square over here, this is a 0 because the small elements are there, and this is our Ig. Now Ixx is equal to Ig, Iab is equal to Ig plus Ah square. So you have to memorize this theory, and this is most important for us. Another perpendicular axis theorem. In this case, the equation for this Izz is equal to Ixx plus Iyy, and this is very much useful for the circular section that rotate about the zz axis. Sometimes we call it is a polar moment of inertia. So moment of inertia of P about x-axis that Ixx is equal to dA into y square. Similarly, Iyy is equal to dA into x square. Izz is equal to sum of that two, that Ixx plus Iyy. So, dear student, this chapter is important for some of the cases that we have to solve in next semester, that is SA1. But till then, you have to memorize these tables of CG and tables of moment of inertia. First, after that, you can calculate all the example. Till then, you can't calculate. So, you have to memorize all the equations for particular examples. Clear? So, thank you. Thank you very much. But you have to go through all the equations, what is Ixx, what is Iyy, and equation for particular shapes, how we can calculate that Ixx and Iyy. What is equation for circle, what is a half circle, what is I base, that all equation you have to memorize. Okay? So, thank you. Thank you very much.